Hey robot makers, how you doing? I hope you're having a good day so far. So do you want to know more about the Arduino Q, the brand new board from Arduino that was launched yesterday? Then this is the show for you. So let's dive straight in. My name is Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let me get over to just a couple of slides just to go through what happened yesterday, and then we'll get to a bit of a demo. Okay, so yes, what is the Arduino Q, you might be asking. If you join this stream, you probably know more about it than I do. So it's a single board computer, unlike the original Arduino boards. I've got my original one just here. This is, as Jeff Gehling said in his post, this is where I learned to blink my first LED. So there's my very first Arduino Uno. I bought this one from Maplins in the UK before that got defunct. So this is unlike that board. It does have a microcontroller built in. We'll get to that in a second, but it's more like a Raspberry Pi. It's a single board computer. It has a full Linux stack on there. Also has the original kind of form factor, so a bit like the Arduino R4 or R3. It's got that same kind of shape to it, and it also works with the ecosystem of shields. So if you have an investment in shields and all the kind of code that goes with that, it'll still work with that. Unlike the original Arduino, it can run full Linux. It runs upstream Debian Linux, so it's got the cutting edge version of Linux on there. I think it's Trixie is what it's running, and I've been under the hood with that today because I made a bit of a mistake just before the live stream. I thought, oh, I'll set up at VNC so I can just share the screen. I managed to make my installation not quite work right, but I've got it working now so I can show you the demo. Anyway, so it also has the STM32U585 microcontroller on, so that's the kind of classic Arduino microcontroller for real-time access to all the GPIO pins, and it comes with this new AppLab software. We'll have a look at this AppLab software in a minute, and this allows you to combine Arduino sketches, Python code, and these things called bricks, which are kind of secretly Docker containers. We'll have a look at those as well. Why is it called Q? Well, it's because this is the first product that Arduino has launched since its acquisition by Qualcomm. Originally, when I had the prototype of this one, we were calling it the Uno R5, but then when I actually received the Uno, it says Uno Q on it, and I'm like, what's the Q? They're like, we can't talk about that just yet, because obviously the acquisition was still under wraps at that point. So let's talk about the spec. So it has a Dragon Wing QRB 2210 processor, quad-core 2 GHz with an Arduino GPU, sounds really fast. Has 2 ISP and 8x13 LED matrix. I think it's a couple more pixels than the Uno R4, so it's got an extra column of pixels on there. Has the quick connector similar to the R4, so that means you can connect all kinds of I2C things to it as well. And it comes in 2 varieties. So available right now is the 2 gig version that has 16 gigs of onboard eMMC storage, plenty of space to store all your projects. They tend to be quite small compared to large video files, for example. And in November, I understand that they're launching a 4 gig version, which will have 32 gigs of eMMC storage on board as well. Comes with the usual kind of things you'd expect from an Arduino now, which is Wi-Fi 5, Bluetooth 5.1, but it also has these rather unusual high-speed connectors. We'll have a look at those in a minute. I don't want to switch it off right now and show you the board. We'll get to that when we do a bit of a demo. I just want to make sure I can show you the demo before we get to looking at the board in a bit more detail. So what is this new AppLab software? So this is how we connect to the board, and this is how we can run Arduino sketches side by side with Python code, and also these brick things that we talked about before as well, kind of like blocks of code that you can that are kind of pre-baked that just work out the box. So it's very much designed to be a kind of plug and play environment. And the IDE is kind of similar to the Arduino IDE, but it works, like I said, with Python. If you have a JavaScript component assets to your project because you're using the web UI brick, then it'll bring in that as well, and it understands all these. It can do all the code highlighting, everything you'd expect there, and it loads as soon as you log into the Arduino Q and is available as a desktop app as well. So I've got this installed on my Mac. We can play with that so I can actually show it to you, and it's also running live next to me as a full-blown desktop computer. We'll have a look at that too. So what are these bricks? So these bricks are kind of software modules. They're actually Docker containers. I've discovered this, entirely by accident. one of the first things I do when I get a new computer is I usually install Docker on there, because all the projects I've currently got working are within Docker containers, and it just makes it easier to install something and then remove it without leaving a trace. So this is essentially what these bricks are. They are kind of pre-baked, bundled Docker containers, and they do a very specific task. So it might be object detection or face detection or running a web server. These things are very, very specific in what they do, and there is a software library that comes with it, so you can bring that into your Arduino code or your Python code and it will just work. So they're provided by Arduino using this new AppLab development software, and currently it's kind of an Arduino control thing, but I understand that they are going to open this up as a community thing, so you can build your own brick and then you'll be able to share that as well. So it will be expanded later. So availability, we talked about that at the top of the show. So it's $39 for the first version, the 16 gig storage, 2 gig of RAM. That's available right now for pre-order, and you can also order in November the 53 euro version, which is 32 gigs of EMC storage and 4 gigs of RAM, and that'll be later in the back end of the year. These prices are all before you pay shipping and local taxes. So I'm based in the UK. I had to pay close to $50, I think it would be, for mine to get that shipped. I did order one yesterday, a second one. If you like what I do and you want me to make more of these kind of videos, if you want me to make more specifically Arduino based projects, let me know in the comments. If you've not subscribed to the channel, please consider subscribing. It means so much to me that people do this. And yeah, if you've not liked the video already, give this video a like. It just helps share it with the algorithm, all that kind of jazz. And I do go live every single Sunday, 7 o'clock British Summer Time or GMT, whichever time of year we're in. So if you want to chat live, I do go live every single Sunday as well. Okay, let's get to a bit of a demo, shall we? So what I'm going to do, I'm going to try and figure out how on earth I can show you this. But first of all, let me just come over here and in fact, let's go to the overhead. So what I've got set up on here, I've got this USB hub. This is kind of an essential thing that you'll need to have if you want to run this as a desktop computer. And there is the Uno Q. As you can see, if I put it on the close to the camera there, so you can see it says Uno Q. You've got that little 13x8 LED pixel display. You've got the Qualcomm chip right in the middle there, and you've got like the Wi-Fi Bluetooth chip sort of bottom left there. You can see it has the usual kind of form factor as the regular Arduino, and if we flip it over, you can see those high-speed connectors. These remind me very much of the Raspberry Pi compute module. So the idea there is any kind of vision or display or audio connectivity, it'll be able to go in kind of a carrier board. And you can just see the quick connector, the white plug just there. So this is what is currently hooked up. This is hooked up to this USB hub here, USB-C hub. So this is powering the Arduino, and it's also providing like HDMI access to this big monitor I've got next to me here. This is a Raspberry Pi display I've just got here. It's also got a webcam on there, and I've also got a keyboard and mouse hooked up as well. So I want to show you the software, but it's probably easier for me to show you the software actually running on my Mac rather than trying to show you this very blurred screen here. So what I did want to do is going to show you something working. So what I'm going to do, I'm just going to run one of the demos just while I've got it all hooked up. So one of them is face detector on camera. I'm going to show you the screen in a second. Let me see if I can get this working on my other camera. There we go. So let me just grab this camera here and try and shove this a bit closer to what's going on. Right, so I've got this Raspberry Pi monitor, and there's a camera, USB web camera on there. And what I'm going to do is I'm just going to click on the run button. I'll show you the software in a lot more detail, so it'll not be as blurry as this. I just want to kind of show you what the experience is like when you run this as a desktop computer. So what it's going to do, it's going to run all these bricks, which it does say containers there. That was the thing that gave away it's probably a Docker container. And it says there, running share Arduino app, CLI examples, video face detection, EI video object. So it's turned green, that means it's now running, and it says that it is now running. So if I click on that Python thing there, if I bring my face towards the camera, it says face detected. You can just see there, face detected. If I hide the camera from my face, it stops, and then if I show my face again, it again is running. It does actually have a web interface as well. I think I might have broken my Chrome install on here. Let's see if that actually runs. If it does run, we can actually open up the web browser and see what it can see. If not, we will connect it up and run it a different way. So I'm just going to stop that from running. Just click on this stop button at the top right. I'll show you this in more detail on the screen share so it's not as blurred. And I want to show you as well that this is just like a regular Linux computer. So I can drop into a terminal. I can type something like htop, for example, and I can see all the kind of stats and things that you would normally expect from a Linux computer. So what I'm going to do now, I'm going to shut this down and then I'm going to plug it into the Mac and we'll show you it running some things that way. So if I go to shut down, I mean, you can just whip the cable out, it's not too fussy about that. So once it's shut down, you can see there that it just runs this kind of Arduino logo thing. It just runs that sketch all the time when nothing's happening on it. So I'm going to disconnect it from there, and I'm going to plug it into my Mac so I can show you the desktop software running from there. So if I now plug that in, so that's now plugged in, you get to see that little logo thing, and you'll see some of the little status indicator lights on the left hand side here, which will then come to life. These ones indicate, if I can get that in focus there, whether it says that STM and what's the other thing there, QRB, so it's the different kind of processors. So that indicates that the Linux side is now booted up, and you'll get like a disk activity kind of light, network activity light as well. So what I'm going to do now, I'm just going to load up the AppLab software and kind of show you what that experience looks like. So here we are, I've got this loaded up. This is the version that's currently released, 1.23. And you see there we've got the board detected. So if I click on that, it'll then just check through to see if do we have a network, like a Wi-Fi network that we need to connect up, and so on. So it goes straight into examples. So you can see we've got all these kind of examples for us to try. And the one I was just running a second ago was the person classifier on camera. If I click on that and show you kind of what it looks like on screen. So you can see on the left hand side we've got bricks. So this one uses the video image classification brick and also the web UI brick, which is a HTML. And then if we click on the files, we can see there we've got some assets. So we've got some PNG files that it uses to kind of talk you through how to do it. We've got some fonts there, Roboto. We've got some images as well. I think these are just like user interface images. And then we've got things like the JavaScript file for running the web front end part. So that's in assets. We've then got Python. So you can see there, this is the Python code. Now, as a Python developer, this looks very, very much like it's been written by somebody who isn't a Python developer. The choice of some of the names, for example. So the camel case name, that isn't a Pythonic way of writing code. Typically you would have little underscores and it'll be lowercase. Uppercase would be for constants. So where you got like the web UI, for example. So little things like that tell me, and just the sort of style overall of the code looks like this has been written by somebody who's very much Arduino based. So that is an example of just kind of a pure Python program. Let's go for one which just blinks an LED, for example. Blink LED with UI. Let's have a look at this one. So this one mixes Python and Arduino code. So we've got the Arduino INO file there. So this one runs directly on the microcontroller, the STM32. So you can see there, just like you would expect on a regular Arduino, pin mode, LED built in, output, digital write high. This bridge helps us bridge between the two different brains of the processor. And then we're going to go in a loop, and then it'll basically just toggle that on or off with that code there. Sketch.yaml, that's interesting there. So we've got a little YAML file that just tells it all the different libraries that are being used. And then if you go to the Python file, we can see that, that it has one of the bricks. So we're using the web UI brick. I find this interesting. You could talk directly to the Docker container locally. You can expose the ports on there and so on and just access it like an API running on another machine, for example. But they've decided to wrap these in kind of regular C code. So I find that interesting design choice. It's got global state there, LEDs on. See, that's more Pythonic. And then we've got LED status, so it's getting the LED from the API. So LED is on, LED is on, it's going to return that. And let's see what else we've got. So toggling the state, yep, understand that. And then this bridge call, so there you go. Calls a function in the sketch using the bridge helper library to control the state of the LED connected to the microcontroller. So this is how the Python and the Arduino code kind of talk to each other, this bridge. Then we've got things like the get the initial state, send a message to the user interface. The user interface is just running this web UI thing, so let's try doing that. I think that one will work okay on here. So it's going to compile the Arduino code as you would do normally, as you can see there, and C code always takes a couple of seconds, even on like a really fast Mac. So let's see what else. So what do people think about the Qualcomm acquisition? I was reading quite a few interesting takes on that this morning. I know Adafruit have quite a strong view on that. Particularly, they're very much open source hardware and open source software, and we get lots of promises from Qualcomm that they're going to treat Arduino as it is now. So we're going to carry that on. There we go. So you can see there we've got lots of things. It's turned blue, kind of this turquoisey colour, which means everything's working. You can see that the containers have started, and it also says that if we go to the Python code there, we can access this. Now I'm not sure I can access this over here. I'm going to try and copy that. So just bear with me while I just get a web browser open. Let me just close down all these millions of tabs that I've got open. I just emailed the guy to Arduino that I've been speaking to say, how do you do a factory reset on this? Because I think I've broken my browser on the install of mine. Right, so if I try and log into, what was it, 177 and port 7000. Right, just bear with me, I know you're looking at my face for a second. And then port 7000. So yeah, I don't seem to be able to connect to this, even though this is on the Wi-Fi and so on. So I'm not sure what the issue is there. It's probably something to do with my weird network setup rather than anything else. But yeah, you get a nice web user interface, and you can kind of toggle the LED on and off. Just wanted to be able to show you that, but that's not currently working for me right now. Okay, let's go back to there. You can see the serial monitor, so if there's any kind of output message from the Arduino itself, you'll get them there. The Python console is on that tab, and then you've got the kind of app launcher tab as well. So it's interesting to see what kind of outputs it talks about on there. And if this was connected up as a full computer, you'd be able to see the Docker containers running in the background as well, which I thought was quite cool. We'll do that in a second. And then to stop it, if I go back to... there's like a start and stop button that you might have just seen there. So I've played around with this a little bit. I've created one so I could just grab the IP address of the machine, just because I wanted to know what that was. If I run this one, let's see. Yep, let's confirm and replace that. So you can only have one app running at a time, and that's more of a way of managing the actual resources available on the machine. So Docker containers take up space. There is a limited amount of space on here. If it comes with what was it, 16 gig of storage, a lot of that is already taken up by AppLab and all the libraries and so on. You'd be surprised how much that takes up. Let's see what I've got there. So, there we go. So the IP address is slightly different. I think that is a Starlink. So if I change my IP to Starlink, let's see if I get this to work. So if I now go to that port 7000, was it? Let's see if we can get that to... if not, that's fine. No, that's not for working for me. Never mind. Okay, so let's go back. Yeah, one of the things I think is missing as well from here, and it is like day one after launch, is how do we access the actual files that are on here? So there's no file browser from here. So where are my apps living? If I want to do a Git repository, either locally or from GitHub, how do I actually find those files and upload them? So that isn't currently exposed in there. So we'll have a look at some of the other examples on there. So another nice one is this Hey Arduino. So this one, listens using the microphone. So if you've got a web camera or a microphone connected up to the USB hub, it can use that and it can listen for certain wake words. That's going to be really cool. I think I'm going to be using that in a couple of my own projects. What else have we got on there? So we have concrete crack detector. Let's have a look what that uses. Visual anomaly detection. So that brick there, that one lets you perform anomaly detection using a pre-trained neural network, making it ideal for quality control, monitoring and automation tasks with Arduino projects. So that's interesting. No problems there, Jeff. Good to catch you on the stream. So what else we have? So that presents itself as like a, you can see there, through this app bricks library in Python. And you've got all the other libraries in there. Got pill for doing image manipulation, some utils, draw anomaly markers, just helps you sort of draw shape around the thing in the image that you've captured. And you've got the usual kind of readme files, so you've got some good documentation there, all in Markdown as you can see there, but you get the nice preview version of that as well. So that's quite nice. You can't do tables in the Markdown, so I think they need to improve the Markdown library that they're using to render this out. I tried writing my own readme file with a little table of like bill of materials and it just didn't understand that at all. So and then you've got these things like the name of the app, a little icon that you can display in the kind of app picker, and what bricks this is using, as well as a description. So that icon displays there on the left the title and the description. Now that's fine if you've only got, you know, a handful of apps. So what's going to happen if you've got like 200 apps? You're going to do a lot of scrolling, I expect, in there. But I'll show you how you can create an app. You just pick some kind of icon, emoji from there, and then live stream app. And then you can give that a description, so you can again then see that's there, and then you can create the Python code. It just gives you some boilerplate code there, and similar with the Arduino sketch as well. So if we just did some amazing Python skills going on here. And then let's just make that into a little f string, and then to say the results are. Like so. So if I now run that code, it's going to compile the Arduino sketch. It's going to compile the, well, it doesn't compile the Python code, it just runs it directly. And if there's any bricks that are included, it will also bring those in as well. So it's surprising, even though there's no code in that Arduino one, it still has to go through the whole process of compiling that. The C compiler takes a little bit longer, but I understand that this is quicker than the original Arduino code. It has these kind of dynamic link libraries, which makes this a bit quicker, as I understand. There we go. So it's now created a live stream container, and we can see there, if we go to Python, it says, there you go, the results are 3. My amazing piece of Python code there. And if we had any kind of serial writes on the Python, on the Arduino side, that would also appear in the serial monitor as well there. So there we go. So if I click on stop, let's go back to my apps and let's have a look at the bricks that are available. So we've got a database brick. I thought this was a really interesting choice because like SQLite is part of the standard Python, so why include a brick for that? And I guess this is more around the storage of the files that are in there, because once you start using up storage on this thing, how are you going to manage that? You would have to either have a file system, and then that gets complicated for the users. But if you make everything into kind of bricks, it kind of makes these containers easily manageable. So when you stop running that app and run something else, all that container disappears, all the contents of it. So it kind of makes things kind of neat and tidy. Object detection, mood detection, that's interesting. So this one classifies text as positive, neutral or negative. It's kind of a sentiment analysis. You've got camera code detection, so this one can read barcodes and QR codes, which is neat. audio classification. So this one can process audio inputs to classify sounds. Works with some pre-trained models. Got the Arduino cloud, so if you want to save variables up to the cloud, you can do that way and present them in your dashboards as normal. Image classification, so you can classify. I'm going to be classifying dogs and cats for a project that I'm going to be working on. I want to make a pet feeder that can classify if a cat comes up to the dog feeder, it should close the container. If a dog goes up to the cat feeder, it should close it. So depending which setting you've got it on there. So I'll be using that image classification for that. The web UI is a nice user interface. It just makes building websites or web pages for your apps very, very simple. Vibration anomaly detection, so that's interesting if you're using accelerometers and you want to detect anomalies within that. So say somebody is walking or clapping or something like that, you can detect that using an accelerometer. So I've got the web UI HTML and this web UI Streamlit. So I need to look into Streamlit. I've not used that one before. Keyword spotting, that's for audio. So again, you can sort of say, "Hey Arduino," and it'll respond to that. We've got the video image classification. That's probably the one I'll be using for the pet detection because it'll be a video stream. That's why I bought the web camera, in fact, for that project. Weather forecasting, again, that just cheats and uses some APIs, but they've taken all the complexity of that away from you, so you can just load the brick up and pass it where you are, and that will work. You've got motion detection, so it can detect from an image if something is moving within that, which is quite cool. Good for like burglar alarm or security cameras. And what else? We've got database time series. So if you're doing something kind of a log file that needs to be time based and you need to be able to search back quickly based on that time series, database is good for that. I think it actually, it does use InfluxDB, it says there, which is the best time series database. I use that for my weather station stuff. And then visual anomaly detection. So this brick is for anomaly detection using pre-trained models. It processes images to identify unusual patterns and returns detected anomalies with bounding boxes. So that's interesting. And then you've got the video object detection as well. So they're all the ones kind of available right off the bat. And then if we go down to learn, you've got the kind of how you go about setting up your Arduino Q. So you can see there. Gives you some kind of background information about it. Tells you all about the pinouts and all the different parts of it. So the USB-C. So one of the things when I had my original Uno revision 4, I got the kind of maximum version of that when I had all the LEDs. I found that the USB-C connector on it was a little bit wonky and it kind of lit it up a little bit from the board with use, and it's quite a short connection. So I was a bit worried that, because these things are not cheap, that the same might happen with the new one, but it looks like they've changed the connector ever so slightly, so hopefully they've learned from that one. So there we go, that's all the pinouts information. What else have we got there? And then you can of course use this with the plug and make kit. So I've got one of the plug and make kits here with all the different modulinos, so it makes it very easy. Just plug in the little quick connector and then you've got access to all those sensors and inputs as well. So that's pretty cool. So that's kind of like learning your way around the Uno Q. Then there's the first setup, talks about how to use AppLab. You can either use it like I'm doing right now as a desktop USB, so you connect it up like you would traditionally. You can use it remotely where it's powered on and you just connect to it remotely. I'm not sure how you do that yet. I've not actually tried that yet. It says by SSH. It's probably on the wrong network. That's why I'm having issues there connecting to it. And then the single board computer. There we go. So that's kind of what I had at the very beginning of the show there. So let me just click on that. So just having a bit of a Wi-Fi connectivity issues there, I think. It's going to disconnect myself from that. And it should return in a second or two. Not sure why it's slowed down so much. What else have we got on here? Let's have a look. We have what is an app, So this kind of talks through all the different parts of the app. So Python, sketches, the app.yaml helps contain information about the app itself. And you've got things like the sensors, which are running on the microcontroller side, and then you've got the Python stuff like the web UI bricks that are running there as well. Okay, just aware that the stream might be a little bit laggy at the moment. It'll catch up. If you have any issues, just press pause and then it'll catch up momentarily. Okay, so what I'm going to do now is plug it back in as a desktop computer and play with some more of the demos on there, and I'll try and show you that using the different cameras that I've got here. So let me do that first of all. Okay, so I'm just going to disconnect it on here and then plug it back in. Let's go to the overhead. So I'll show you on the overhead camera there what this looks like a little bit better. So there's the Arduino Q. You can see the high-speed connectors there. And if I have this one side by side with an original Uno, you can kind of see the side by side. It's the same form factor, but it hasn't obviously got the massive connector there, and it doesn't need to have the 9-volt, 5-volt barrel jack as well. And they go side by side from the back. So it will work with all the original shields and things. Don't know if I've got any of those shields to hand. Probably. So I could plug in, for example, one of these shields. And they'll work just the same as they always have. So that whole investment of code and libraries, open source stuff, is already compatible with this. Right, so let's get this plugged back in. I'm just going to plug it back into this desktop hub. This desktop hub is being powered by a Raspberry Pi power supply. I think I've got on my notes on here about the power usage. I know that's something Jeff Geeling's going to be looking into. So it uses around about an amp is what they said power wise. Sorry, was it 1 watt? I think they said rather than amp. You needed like a 5-volt 3-amp power supply to power it, but idle it should take up about a watt, so it should be quite low usage there. Okay, right, so now that's booting up. Let's go to this view. So first thing you get is this kind of login screen. If I type the right password in, it should help me log in there. This is what I messed up before. I'd installed VNC, which is a software for remotely sharing your desktop, and I kind of messed up a little bit, but it's working again now. So you can see AppLab launches as soon as you've logged in. So that's the interface that we were looking at before, but let's try now doing some different ones. Let's try that web interface LED project. So blink with UI. Let's see if I can get that working. So if I press start on there, it'll start building that and compiling it. So somebody's asked, does it run Doom? Right, I can answer that question. I've installed Chocolate Doom on here because I wanted to know that as well. Does it run Doom? It does run Doom. So you can have Doom running. I'm not best at Doom. I've not got any speakers attached to this actually, so there you go, it is actually running Doom. So let me just turn off these overhead cameras for a second. You can see there, running Doom. There we go. So yes, it does run Doom. Thanks for that trash cutter. Quit to DOS. There we go. So I had to install that. That's Chocolate Doom that I installed there for that. Cool, so it's starting the app. This is the LED one. Let's see if we can get the web user interface to sort of show up on here as well. So yeah, for some reason my Chrome is stopped working. What I'm going to do is open up a terminal and just see if we can get that to reinstall Chrome. So sudo apt install chromium reinstall. I don't know what I've done there to mess that up. So this is a regular Debian Linux, so all the usual things that you can do with that. Let's open up another terminal, in fact. And if we type in docker ps, we can see, if I can get that to near the screen, you can see that there's a Docker container running, and that is the app that we've just got in the background there. So as soon as this Chromium is finished installing again, I don't know why this got messed up, why it keeps crashing, but let's see if we can get that to work. Again, I'm not sure why my internet is being so terrible at the moment. Right, let's try launching Chromium again. Although I need to load it from there instead. So this is giving me a bit of an error message there about Chromium locked profile. So I'll probably need to do a bit of troubleshooting to get that to work. That's a shame because I wanted to show you the web interface. So what's the IP address of this machine? Let's see if I can find that. So I've actually got this plugged in via a network cable, as well as, just checking that that's the case. I've not got it plugged in by cable, let's just plug that in. I'll plug in a network cable and see if we can get an IP address on the local network as well. If we can do that, then we might be able to connect to the web interface for that particular project. So that's the Wi-Fi one. I think the Wi-Fi, is that connected to, yeah, that's my Starlink. Let's change that to home instead. I think I've got 3 Wi-Fi networks in here, which is why it's having a few issues connecting up. And there we go, so I just need to type in a password there. I think I've typed the wrong password in. Cool. Once it's up and running there, we should be able to connect to it from my desktop Mac. It's really not liking to connect to that though, is it? Let's try the other one. Let's try that one. Yeah, I'm not a big fan of this, is it LightDM, this window manager. I much prefer the Raspberry Pi one. The font seems a lot larger on the Raspberry Pi one. This seems quite small, and you can fit a lot on your screen, but yeah, it doesn't seem to make a good use of the screen space to me. Right, let's see if I've got the IP address now on there. So 229. Right, so if I go back over to my Mac, I'm just going to try this on here and see if we can get that web interface that it's created for us. So it's on port 7000. Yes, we can. So this is the web interface. In fact, let's go for that view there. So this is the web interface that this is providing for us. So it says Linux Blink, and if I click on the LEDs off and on, you can see we get that little purple LED there when I click it on and off. So this web user interface is the Blink the Blink container and the web user interface, the web UI one. Right, now that that's working, I can then go back and let's try a different let's go back to that view there. Let's try a different one then. So let's try that face detector. Let's see what happens with that one. Click run on that, confirm and replace, and then let's go back to that web interface that we have on here, and let's see if we can once it's built that container and it's running again. At the moment it'll just say can't find any page until it's brought that up. So the idea of these bricks is that it makes it easier for you to develop things. the thing I think is missing from that is how do you get things in and out. So currently everything is stored on the Arduino Uno Q itself. So how do I connect GitHub up? Where's the file access for that? Let's see if this has got an interface. I thought this one did. Let's have a look. There we go. So I now refresh that. There we go. So it can see my face, and it's got a confidence level as well. So I just move this up here a little bit. So it's detecting face. It's detecting face fine. Let's see what else. You can see there the recent detections, the confidence level. Oops. And it says if I cover up the camera so it can't see my face, it says system response will appear here, so it can't actually see my face there, but then it can see it again. So this whole interface, or this web page, let's go full screen on that one so you can see what it looks like. That whole thing is one of the bricks, and they've made this really easy to set up, and it looks pretty professional. It looks nice and polished, sort of nice rounded corners and things. I like that little animated hi there thing. So it's only 0.87 convinced that that's a face there. So there we go. That's one of the face detection ones. Let's stop that from running. So I'm going to stop that running there, and then I'm going to go back to the examples. Let's have a look what else there was. There was one which was something to do with sound. So we'll detect objects on camera. Person classifier. Let's try person classifier. I don't know what that does. If it doesn't have the Docker container, it will have to download, if it doesn't have the brick I should say, it has to actually download that from the Arduino repository of bricks. And they're building that out all the time, so I'm sure by the time you get your hands on this there'll be a lot more bricks available than the ones that are just being shown at the moment. A very serious looking face there, right? So if I just refresh that, it should time out, and then once it has finished building this container, and to say it's waiting for it, we can then play with it. And it'll carry on running. One of the things about Docker containers as well is they start up when you boot the machine, so they will always be on. So whichever app you built will automatically start, just like an Arduino sketch will run as soon as you plug power in. It's the same with the Docker containers. So there we go. So this one is now person classification. So it's confident that there's a person here, but interestingly it's not drawing the bounding box around my face. Interestingly, it's still detecting that as a person. And you can change this confidence level as well, and then you can bring that right back down again. So let me just share my screen there. I was doing this and you can't even see what I'm doing. There we go. So it's detecting that I'm a person. You can see that the confidence level that it has there. I just move my little face out the way. You can see the whole thing there. So yeah, it's detecting that I'm a person, and that's working fine. Cool, let's have a look, see what else examples we've got. I'll leave that one running for a second. Let's go back to that view there. Hey Arduino, let's try that one. So this one is an audio based, like wake word one, I understand. So I just need to confirm and replace that once again. So James is asking, what cams are you using? So this one, I think it's a Ugreen webcam. It's just like a cheap webcam from Amazon that I got yesterday. In fact, I've still got the box for it just here. So that's the webcam that I'm currently using with it. It's just like a USB connector, 1080p, so nothing particularly fancy. And it says at the moment this is just building the containers again. So compiling the code and building the containers. And you can switch between the console and the actual files as well just by clicking there. And you can see this one does have a mixture of Arduino code and Python as well. So this one it's basically awake or not awake, and we have the Python code there, which is the on keyword detected. So it just comes back and says, yep, Hey Arduino's detected. So let me see what the console says. Let's try running that again. For some reason it stopped. And then once that's run, if we refresh that, we might get a web interface. I'm not sure, does this actually use a web interface? Just says keyword spotting, so maybe it doesn't have a web interface, this one. Yep, you can use any web camera, that's right, any USB web camera. It just seems to work fine with it. I've not had any issues with any of the peripherals I plugged in. So what I've currently got, if I go to the overhead there, I've got this USB hub there. I think that's also a Ugreen USB-C hub. It's got an Ethernet connection on it, HDMI. It's powering up this is from a Raspberry Pi 27 watt power supply. I've got a keyboard, Raspberry Pi keyboard and mouse plugged into this as well. I'm actually running this on a Raspberry Pi monitor as well, just there. Okay, so this one is now waiting for that container to start, and it's starting it, and it should use the audio from the web camera. So let's see. I'm not sure where the actual display. If I say "Hey Arduino," "Hey Arduino," see if it detects any of that. Not sure where it's going to show me that as an output. "Hey Arduino." So I'm not actually seeing any responses when I say "Hey Arduino." Maybe I'm not saying it Italian enough. "Hey Arduino." Nope. That didn't work. So it says you can connect to it. Let's try that. What is that? I'm just looking at the screen there, and it's just saying, yes, that one's not working so great. Let's try a different example. So we've got the face detect objects on camera. Let's try that one. Let's click on run. Change and confirm, yep, confirm and replace. And then it's just going to pull down any of the bricks that it needs for this one. So it will cache the bricks once they've downloaded. So you don't have to download them from scratch every time, but it will manage the storage for you, so you don't have to worry too much about space on there. If it runs out of space, it'll just clear up any containers that are not being used, as I understand it. Okay, so just waiting for that one to do its thing. So I'm just going to look through the questions that people have been asking in the chat, see if there's anything I can answer for you now. So Alan was sat in his chair with a mug of tea waiting. And the usual crowd from Sunday saying hello. We had Jeff Gilling earlier on as well. He was joining to see the thing in action. And we have Ford and Cassie. Let's see who else we've got. Oh, there we go. So it's detecting various things. Will it detect a phone? Let's see. Does it detect that as a phone? Remote, you thought that was? What else is it? Does it know like soda cans? Diet Pepsi? Nope. I don't know what the list of objects is that it can detect. What else have we got on here? Just looking for things it might recognise. I don't know, a screwdriver. Nope. How about some scissors? Detecting me as a person twice, which is interesting. Oh, no, it's not recognising the scissors. They usually do detect that. It's just running straight on the process of this. It doesn't have any kind of special AI module. It's kind of accelerating a bit like the Raspberry Pi camera. So there's none of that. It's just straight on the CPU. There we go. Oh, it does recognise my chair as well, interestingly. Sometimes they detect that, if I get my finger in the right place, that light above my head there, it's like a bowl or a toilet, I think once it detected it as. So yeah, that's I go full screen on that, you can see all the things that it's detecting, chair and person. So that one works fine. Cool. Let's have a look. I'm just going to leave that on there actually. Let's have a see what everybody else is talking about in the chat there. Let's have a quick look through. Robot fellas. Let's make that a bit smaller there. There we go. So Jess says, I wish it would have two quick connectors, one for the MCU and one for the CPU, but you can access them all the same. I don't know why that would be of benefit. Just explain to me why that would be cool. Will you show it IRL? So yes, I'm showing it IRL. There it is running right now. And it's running this, you can see in the background there. So James says, I'm excited, but all the same, at the same time, what is Qualcomm up to? I think you grow these companies and you get to a point where you're like, what else do we do? What's the next step? Raspberry Pi had the same thing a while back. They decided to do their own IPO, but they could get bought up now just the same. I think they bought Arduino to make their dev kits more accessible. It does. It loves me as a person detected. Does it still have short protection on the pins? Yeah, I believe it's all the usual kind of protection that you would normally have on an Arduino. It has all that kind of stuff. So 5-volt tolerant and so on. Java developer writing Python detected. You said it. You had a run with Arduino. Qualcomm, I've killed it in 3 years. Anyone will take over. Interesting. I suspect Qualcomm was seeing Broadcom's involvement in Raspberry Pi and decided they want a bit of that. I remember when I was working for HP and they bought who was it they bought? No, they bought EDS, Electronic Data Systems, which is like a huge corporate thing. They had all kinds of things in government contracts and so on, and they basically just want to sell more PCs and printers. So that's why they did that. Is what I understand. So aiming for the over or the under. What do you mean by that, Greg? So much better than... So this is much better than Arduino IDE. So that's an interesting take. I'm not sure yet. I've used the AppLab and it's very much tuned for this kind of thing. I don't know why they couldn't have just built this functionality into the regular Arduino IDE. I guess they wanted to make the Arduino Q kind of special in that way, make the experience a bit easier. What is this? So if you could measure the power consumption and T-flops, that would be great. So what kind of benchmarks you want me to run on this? I can run any kind of Linuxy benchmark. So let me know what you want to install and I will run that for you. Hope they ship before the end of the month. Cool. Yeah, the number 3 thing is like how much you've contributed to the chat. So Ford is always number 1. I'm not sure who's number 2 on there. Does it say who the top fans are? Yep, Jeff Johnson is 2. Jeff Gilling is 3. Measure teraflops per watt. Interesting. Yeah, I think Jeff's got better setup for measuring how much power. I think I've got one of those Elgato Eve home automation things, and that tells you how much power it's using, but I'm not sure how accurate they are. Love he's got Clippy behind him on the thumbnail there. Hope they shipped to East Africa before we got the Chinese version. See, interestingly, yeah, I don't think there'll be as many clones of these about. So if you think like the original Arduino Uno version 3, you can buy these chips. You can buy these ATmega 328Ps, whatever they're called. And I've got a bunch of them up in my little spares thing there. So you can actually make your own clones. I've got a bunch of clones of these as well. did have them just off camera, but I'm not sure I put it. I've got some. There's a knockoff clone, but they're open source hardware, so you can clone them. That's completely allowed and legitimate. And I understand that this is also open source and open hardware, but it's not been certified, so I think it would make people a lot more comfortable if they did go for the certification. Could this be run a version of Obico? What's Obico? I'm not sure what that is. Just Google that. Obico. So open source smart. So it runs full Linux, so you can install anything you can install on a regular Linux computer, you can install on here. So it should be able to, is my understanding. So yeah, Benjamin says you won't get a Chinese version because it's proprietary design in comparison to the other Arduino products. It's a lot more like Arduino Pro boards. And yeah, I thought the price was okay. I think like $39 is okay. I didn't seem to have a problem with that myself. I think they'll sell a lot of these. You cannot buy Qualcomm CPUs like STM 80 megas or ESP MCUs. Very true. So it's a lot more like Raspberry Pi SBCs. Is there any Raspberry Pi Chinese clones? No, because it's proprietary design. Arduino core boards used to be completely open hardware design. So yeah, Josie Prusa posted something interestingly recently about open hardware, and you know, essentially, if you have a company that provides open source hardware, you get all the support requests from people who have versions of your hardware that you've not produced. I don't want to call them knockoff because it's legitimate if it's open hardware. But yeah, how do you manage that then? So you're putting all this effort and energy into supporting a platform and you're getting no reward back financially for that. So it's just like a big sink. How do we make that work economically? That's the challenge, I think, with open source hardware. Extra Zeds into the stream. No worries there, Alan. So yeah, we had it running Doom, Chocolate Doom. Runs quite nicely on there. Yes, XFCE, isn't it? I know that because I damaged my installation of that and had to reinstall that just about 5 minutes before the stream. But luckily I got it working again, so you can actually see the demo was working. So there's only one app allowed to run in the background. That's correct, Benjamin. That's what I understand. Hey Marie, how's it going? So yeah. So the camera was a Ugreen camera. This camera is a Sony camera, and this one is also a Sony camera. This is like an Alpha something or other. And that one is also an Alpha. So the expensive lens on it that gives you a nice bokeh effect behind me. But yeah, the regular web cameras, the one that's pointing, this one is just another cheapy web camera as well. In fact, I can probably show that on the overhead. That's that camera that's just pointing at it like that, just so I can show you what's going on there. Yes, we have all kinds of cameras like that you can see. If we go back to that one, this is kind of my bench cam and demo cam setup. I think there's an effect on the LED matrix. That's right. So when you boot this up, this kind of does a nice design. If I shut the computer down, let's go for that and shut down, and click on shut down. Once it's powered off the main Linux computer, it runs like a sketch, which just shows like an Arduino animation. So once it's finished doing that, we should also see there that the bottom of the screen is now paused, and you can see there it's got this nice animation. So these are kind of blue LEDs. It looked white on the advert that they did, but the production versions have blue. That's nice. Just the Arduino logo. And it'll just keep doing that while there's power attached. And if I hit the reset button, it'll boot back up. I can see on the screen there that it's booting back up, and we should also see once it's finished booting back up that the example that we're running will also kick back into life, because it should run the default app. If I just log in there, it should run it. as soon as it's kind of powered up. New toy in the block, absolutely. I was so pleased that I got picked to have one of these early on as well. That was very cool. So I'm going to make some cool projects with this. Like I said, the cat feeder. I've got the 3D design for that kind of worked out. You've got a nice little heart thing on there as well. That's pretty neat. And it should, in theory, run that that app that we picked before. Maybe it doesn't do that automatically. Interesting. So we can go back to the face detector. Run that one. I give that a refresh. Yeah, still not working. So there we go. So I'm just going to run that face detector on camera again. Cool, thanks for that. Yeah, it looks pretty good, doesn't it? Pleased with how this is working out. It's kind of made me get my whole Arduino stash of things out and have a play with them again. It's been a while since I've worked on any Arduino projects. I tend to use Raspberry Pis, that whole ecosystem. Yeah, the Arduinos are still quite expensive for what they are compared to other, like ESP32 for example. That's quite a cheap microcontroller, but ESP32s can't run a full Linux stack like this one can. So yeah, it's pretty cool. Cool, so there are all the demos I wanted to cover off. Let me see if there's anything else on the notes that I wanted to talk about. So we've done the turn off an LED via a web page, the camera face detection, we've logged in as a desktop user, shown it's regular Linux, we've shown Doom running as well, shown that the Docker containers run in the background. Yeah, so my question is a bit like a zebra that's black and white. So is a zebra black with white stripes or white with black stripes? Is this board an SBC with an Arduino MCU, or is it an Arduino with a Linux computer attached? Which way round is it? And I think those LEDs are going to be quite fun to play with as well. Quite like what they've done with that. They make that very easy to work with. So let me know in the comments what you think. If you're going to get one of these, are you going to wait until the 4 gig version comes out and buy that, or are you going to get the 2 gig version now while they're available? I suspect they have a lot of them ready to go, but you might have to wait a little while for them to sort of come through. Yeah. Cool. So I think that's everything that I wanted to cover off on the main part of the demo. Let's get back over to my main keynote. And I just wanted to cover off a few other things if you're new to the channel. So we do have a Discord group, kevsrobots.com/discord. We do have a website, kevsrobots.com, where all my projects are posted. So join the Discord group if you want to share projects you're working on. And you can follow me on all the usual kind of social platforms. So Kev McAleer at threads.net on Threads. I'm on TikTok, Kev McAleer6. Doing all the... No. And I'm on Instagram at Kev McAleer. I'm on X at KevsMac, on Mastodon at KevsMac at mastodon.social. I'm also on Blue Sky, kevsmac.bsky.social as well. So if you're on any of those platforms, follow me and say hi and show me a picture of what you're working on right now. And if you want to get your name in the end credits of this video, you can do that by doing a super thanks, a super chat, joining the YouTube membership just by clicking join at the bottom of the screen after you've subscribed, of course. And you can also buy a coffee as well. It's just as like a one-off or as a monthly thing as well, and you'll get your name in the end credits. So let's give a shout out to all the people who've done exactly that. So over on the left hand side here, we've got people who bought coffees. We've got Charles Stevenson who bought me 3 coffees. Thank you very much for that. And Marie-Louise Mayer who bought me a coffee. Thank you again. Got 2 new members. We've got Pietro and Michael who joined very recently on the Buy Me a Coffee side. We've got Warren. Somebody wanted to remain anonymous. They don't know why finding out that they're paying YouTubers for content. I don't know. Silicon Fiber, got me, Marie TKD, Jeff Johnson, DN Corty, Marlene Brent, and Tom. And then on the YouTuber side, we've got Marie Mayer. I think you're new. You've just renewed, I think. We've got Pete Barnes, who is new. We've got Dale from Hybrid Robotics, Oxford39, Warren Packard, Brian, Pierre Eves. We've got Bert, Michael, Steve, Ford, Bello, Johnny, Stephen, John Paul, Cassie, Johnny, and of course we have Tom. So thank you all for supporting the channel. It means so much to me that you do that, and it also sends signals out to the likes of Arduino to send Kev free stuff, which is always a cool thing to do. Cool. So if I go back here, the spinny logo and the little thing there tells me it's at this point in the video that YouTube will be recommending over here another video for you to watch. So definitely check that one out. It's been handpicked by the algorithm just for you, and I shall see you all next time. Thanks for watching. Bye for now.